Oh, so I can tell you one half of a funny story from yesterday. Because we're currently recording. The other half is, well, here I can modify the other half if you'd like. So here's how it went down. This is on the golf course yesterday. The Bev cart girl who I'm friends with, she used to be a waitress over at First Watch, and I knew her from there and got her on at the club. Apparently, she got hit by a golf ball. So she was hiding behind a tree, which is what you're supposed to do when people are teeing off, and the guys didn't see her, so didn't know to yell for, like, look out. And she just got cracked in the knee with this golf ball. And they didn't even know until they came up and found her sitting there, like, in shock, crying. So that's the funny part. No, so she was okay, but she was hurt, so she's heading back to the clubhouse, and she drives by the first hole that I was on with some of my buddies, and some of my interactions I have with her are somewhat I don't even know. Yeah, strange, somewhat strange. So I thought it was her, and I kind of yelled because she's out on the road heading back to the clubhouse, and she'd stopped, and so I have some dialogue. And anyways, so let's just call it strange dialogue. And so she drives off. So then I find out. So before that, I hadn't known that she got hit in the leg with a golf ball. So then I find out about 10 minutes later, because another guy joined our group, said, "Oh, did you hear that Anissa got hit with a golf ball and she's hurt?" And I said, "Oh, I didn't know. I just saw her." Well, so we didn't. I texted her, make sure she was okay, blah blah blah. And one of the guys in the group was a lawyer, so he wanted to make sure that she let the club know. That's for workers' comp, that kind of stuff. Well, then we get to the seventh green, and a bev cart comes around, and this person looks shockingly like the person, looks shockingly like Anissa, because they're wearing their jacket and sunglasses, and so from a distance, you could certainly mistake these people, and I had never met this one before. And had I had this strange conversation with a person for the first time, it would be strange. It would be strange. And she was acting all awkward. But we said, "Oh no, we're good. We don't need anything." So then I would walk back to the green. The guy said, "Who was that?" I said, "I don't know. First time I met her. At least I hope it's the first time." Turned out it was the first time I met her. The strange conversation was with the person I do know, who was back out there today, so she's fine. But it was interesting.
That was incredibly vague.
I may have had some stuff to explain. See, it would be like equivalent to. There actually isn't really an equivalent. There's not an equivalent. It was just strange. It was a strange encounter. Okay. So, you remember last time, we were talking about our Coinbase API. We wrote a little program. We created some classes of our own, Json Parser and Json var, for parsing simple JSON on our own. So, all right, so we open up the URL, open up the connection, read it in, pass in the JSON string into our class we created, the Json Parser, then we tell it to display itself. And it gives us some output. If you remember, inside of our display, Json Parser, we're actually doing some checking to see if it contains US dollars or BTC right now. That way we're only showing US dollar based stuff. Okay, so when we call display, it's going through our JSON string, taking out the opening and closing curly brace. That's what we're doing right there. What does trim do? What does the trim function do? White space on either end, not in the middle. So trim takes off white space on either end. Okay, then we're going to split the thing on commas. So that should give us all of the variable name value pairs. And then we decide we're going to display them nicely to the screen through our var thing, where we pass it in, we split it on the colon, get the first part, get the second part inside of a name and a value. And then when we display it, we'll display the name, followed by an equal sign, greater than, kind of like a little arrow looking thing, followed by the value. But the only ones we're going to display with our current version of the display method in Parser is anything that contains US dollars as well as BTC. So that should be US dollars to BTC as well as BTC to US dollars. And BTC is the shorthand for Bitcoin. All right, so when we run this, we'll see that giant wall of stuff, which we can see here. This is what we would have read in, something that looks like this. We've parsed it apart and have now ended up with something that looks like this. Current value of Bitcoin in US dollars is $405, or $1 US is 0.002469 Bitcoin. Make sense? Okay. Now, this is all fine and good for giving us some high-level information about Bitcoin information using Coinbase's API. So that was kind of our starting point for looking at an API. But realistically, if we want to move towards being able to authenticate with Coinbase and convert between US dollars and Bitcoin and things like that, we need to be able to talk to Coinbase as an authenticated user rather than just doing a global GET request and say, give me a wall of text that allows me to pull some information out of it. Make sense? But with what we've done just here, we could actually create probably a fairly simple, so as an example, I'll pull up an app here. So the app I use for checking the current Bitcoin price is an app called CoinDesk. And this is what the main screen looks like. So really, there's a couple other pieces of information, but basically it's a screen that just shows the current price of Bitcoin. Aren't we pulling that exact same information right here? Number's a little different. Why is the number different?
Because that's a different site that you're using.
Okay.
That's their sell price, that's their sell price.
Okay, pretty much close. So there's all sorts of exchanges, all sorts of locations around the world that you could potentially buy Bitcoin. So for example, I think we have a new exchange online that's not very popular yet. The patriarch here, I guess, is selling Bitcoin on eBay. Right? Okay. So now an option for buying Bitcoin might be on eBay. Why would somebody want to buy Bitcoin on eBay? As opposed to buying Bitcoin directly through Fuse. New nickname, Fuse. There's a backstory. Okay, go ahead.
It would cut down on the amount of information that you would have to have about Bitcoin. It'd be easier to use, I guess.
Okay.
You can just buy it off of there instead of having to go through, make a wallet, do the exchange.
Okay, but if I'm going to buy Bitcoin from him on eBay, I'm probably going to be paying with PayPal, right? So I'm going to pay you US dollars in PayPal, and I'm going to expect you to send me Bitcoin to some Bitcoin address, correct? Now that's going to require me knowing something about how Bitcoin works. Where if I'm going to buy from you, how am I going to pay you? Maybe I pay you cash. Maybe I send you a check. Whatever it is, and I'm going to rely on you then sending me the Bitcoin to some Bitcoin address. So really, I kind of have to have a similar confidence both ways.
But PayPal has the security.
So if I buy from him and I send him an envelope of cash or swipe a credit card or something like that, whatever it is, however I pay him is going to dictate the security of that that transaction, because he can choose not to send me the Bitcoin and that's not traceable. Where on this side, the whole sale happens underneath the umbrella of eBay, as well as fees. So, Abe, did that transaction end up going through? Everything worked? Okay. So he sold Bitcoin and ended up selling it at a premium. But keep in mind that eBay then took a cut of that sale, right? So your sale price was $12, right, for what you sold? Okay. So eBay is going to take a percentage of that $12. You know what they took? 10%. So $1.20. So they took $1.20. So really, you sold it for $10.80. Still a good deal. Still a good deal, right? And you're protected by the sales process of eBay, as well as the transaction of PayPal. So if you were buying Bitcoin from Abe, you might be paying a premium, but you're also protected underneath the flagship eBay, which you're going to trust because it's been around for a while. Another option you could buy Bitcoin is through Coinbase. Now, how many of you heard about Coinbase for the first time in class here? Most of us, right? You know, it's a Bitcoin business that was born along the lines of Bitcoin. Kind of this whole idea that we've talked about in this course about this infrastructure being built up around this cryptocurrency thing. So most of us don't know Coinbase from Adam, right? We don't know how trustworthy they are. I've used it, and I don't know who the people are behind it. You know, we've all, at least most of us, I assume, have used eBay to some extent. And even then, we don't necessarily know all the stuff that happens behind the scenes in eBay, but it's been around long enough, and enough people haven't gotten screwed over with it that we gotta trust it, right? You would trust eBay. I've used the example with other folks. You know, if you bought something off Amazon, would you have any reservations sending Amazon an envelope with cash in it, expecting them to send you your product? I mean, that's weird, right? But if you sent an envelope of cash to Amazon, you would trust they would probably send you your product. The problem in there would actually be whether or not the cash arrived. That would be the real concern in that transaction, right? Because we trust Amazon. So it all comes down to kind of a trust thing. So maybe people on one exchange, in this case, the Patriarch, were buying stuff from him on eBay, and even though we're paying a premium, the chances of us getting ripped off are slim, outside of the cash value premium. Okay, so when we have two different numbers here, 405 on here, we had 402 on CoinDesk, there's 4 or 5 large Bitcoin exchanges around the world. These are places that do volumes of Bitcoin buying and selling. All right, now every place that provides a value may use one or more of those exchanges. I think that Coinbase uses an average of their own price and 2 other exchanges' prices. CoinDesk, I'm not sure what their algorithm is, but the reason those numbers are different is because there's a bunch of different exchanges and it depends on where they're pulling their data. You know, Bitcoin might be going for a different value in a different part of the world. Sometimes you have more volume in one place than another, and that drives price up or drives price down, all sorts of stuff. Okay. So, that's where we get the fluctuation in Bitcoin price. Now, we want to be able to do a transaction that has, let me make this a little larger, that can give us a little bit more personal information about our account, about our information here. So, for example, do I have any Bitcoin in my account here? Hopefully, I think I have a couple. Let's go here. Yes, I do. I have 0.0103 Bitcoin in here. So we'll be able to pull a balance. So there'll be something in there. Okay, so given that, let me go back to the API. We need to deal with authentication first. So if we click on Getting Started under the Bitcoin API here, things that we can do, buying and selling Bitcoin, sending and requesting Bitcoin, accepting Bitcoin payments, securely storing Bitcoin and creating Bitcoin wallets, so we can use the API to generate a wallet. So if we wanted to build our own kind of eBay type place or competitor with PayPal, we can do that. The ability to handle microtransactions and recurring payments. We're probably looking more at this microtransaction type thing. We want to do a quick little conversion, make our payment, and be done. That way we can avoid credit card fees. Okay, so when we go under getting started here, the very first thing we need to deal with is authentication. We need to authenticate ourselves with Coinbase. So underneath here, we have two different ways of authenticating, two different ways of talking to it. We can use an API key, which we'll create here in a second, as well as something called a secret, which it explains below. Or we can use this protocol called OAuth 2. And really what OAuth 2 is for third-party applications, for you to be able to provide something to them to access your information without having to give them like usernames and passwords and things like that. All right? So if we scroll down here, we look at the API key as well as the secret. This is probably the most secure. We recommend this option if you only need to access your own account. And that's what we're going to be doing in this little example. So anybody who opens up their app to do the, to pay at McDonald's via Bitcoin, when they open up the app, they're going to be accessing their own account, correct? So they would have their own credentials in that, and we put our username and password into apps all the time, correct? This is actually even more secure than that because we're going to be calculating some information about it. All right, so the first thing we need to do is we have to create an API key and set what actions are permitted to make with it. And we're going to do this inside of our account settings. So I'm going to go ahead and click on that. Here's our API. You haven't created any API keys, so I want to create a new API key. One second. I have a two-factor authentication turned on. I'll give you an example of how this works too. So I use this app called Authy. And I need to go to Coinbase. So it's giving me a number that's good for 20 seconds. So I need to type that in, 9902399. I'll click verify. So now it believes that I'm actually the person who's using the website. So it's, if you've ever seen something that recommends two-step authentication, I'm logged into my account here using my username and password, but I'm trying to do something that they consider to be somewhat secure. Like maybe sending Bitcoin to somebody would fall into the same category. So they made me use a device that I've also set up on here that has a kind of a rolling password, if you will, to prove that I am who I say I am. Okay, so for my accounts, what do I want this API key to allow access to? So I want it to have access to my wallet. What permissions do I want it to have? I can give merchant position permissions, balance, addresses, buttons, buy, contacts, order, sell, transactions, send, request, transfers, user, recurring payments, OAuth apps, and reports. Well, just for the sake of laziness, we're going to say we want this to be allowable for everything. I think we're okay with only having 0.01 Bitcoins in this account. We're safe. Okay, what's the worst that happens? We lose that. Okay, so we can also choose to only allow this API key to work from a single IP address. Now, if we want this thing to work on smartphones, as you are traversing the world with your phone, your IP address is going to be constantly changing. So your IP address is the network address that uniquely identifies your phone on the internet. Verizon's towers, AT&T's towers, whatever. And that's going to be jumping around as you switch from tower to tower, potentially. Okay? So in this particular case, we don't necessarily want to put in a single IP address that says this API key should only work from this source IP address. Now, if we were creating a server somewhere where we had a static IP address, something that wasn't going to change, we could put that in here. And then even if somebody was able to get our credentials and our API key, some of the secure information, they could not use it unless they had physical access to the computer that we were implementing this from. Okay? So we're just being as insecure as possible. Unsecure. I think it's unsecure. Huh?
Insecure.
Insecure is a word, but I don't think it means the same thing.
Insecure is like when
You don't feel good about yourself, right?
unsecure.
I want to say like lack of security. We're careless about security. Okay, this is not what you want to do if you are a private person who cares about security. But we're going to be lazy so that we don't have to come back and do this again. All right. So I'm going to say I want access to everything down here. And we can even say I want access to everything up here, even though there's only one thing. I only have one wallet set up with them. The only thing I use Coinbase for is turning US dollars into Bitcoin, and then I move those Bitcoins out of there to some of my other accounts in other places. Okay, so under security settings for IP addresses, I'm not going to put anything in there. I want to be able to access this from anywhere. All right, no, you cannot help me. All right, so here we go. So we have a key that we've created. It is currently disabled. We can enable it over here. It has access to all accounts, all permissions, no IP restrictions. Here's our actual key, and I bet you if we shrink this down, it'll start. Nope, it just looks like crap. Good. So we'll go ahead and click enable. For your protection, we require new number 664-1372. What? What? Oh, no, this is email. Email verification. Man, this is even harder. Hold on. Hopefully the email works. Here we go. Yep, got it. Oh, come on. Yeah, we're not I'm not Thank you. Here's your verification code. Pick your favorite 256-bit hex value. All right, so now we're enabled. Okay, so we have our key. Let's. I'm going to keep this page open. I'm going to open up Coinbase API. Let's get back to that other page just so we can reference back to that. Okay, so we're down here, and we are doing this the version of this called API key in secret, and we just created that key, so we have that guy. All right, so we've done all this. All requests need to include application/JSON, content type. So it's all this header crap, stuff that we didn't have to deal with when we made a GET request. GET requests are really simple, and that's why they're so easy, and that's why we did them first. But now we're going to have to do a POST request where we're going to have to send it some additional information proving who we are. That make sense? So, as an example, if we did a GET, actually it shows that we can actually authenticate with a GET. We just have to give it additional things, but we would do this with a POST. So we're going to pass it a header value access key. Here's our API key. We're going to pass it an access signature, which is going to be a computed value using SHA-256, the same thing that Bitcoin uses. Okay? So we're going to see how we can create those hash values. And then we have something called a nonce. Now, a nonce kind of works like this third or two-stage authentication, where, except I guess it's even worse. A nonce is a random integer. And every single time we make a call with our access key and our access key, the nonce must be different. In fact, it actually has to be an ascending value. So if we just start with a 1, let's say the integer is 1 for our nonce, we're going to use that 1 along with our key, potentially along with something else. I don't know what the requirements are, but at least our key and that nonce with SHA-256 hashing to create a one-time signature. A signature that's only good for that one request. If we want to make another API request, we have to generate another nonce, and that nonce has to be higher than the previous nonce. So that's kind of I'm making the assumption that's how theirs work. That's kind of the definition of a nonce. Nonce is a random integer used for communicating with the API where the current nonce must be larger in value than the previous nonce. Doesn't have to be one larger, it just has to be larger. Okay? But this access signature, this is computed on a per call basis. And the reason that it will always be different is because our nonce is always different. Make sense? Okay. So in this particular case, this is a GET request where it's asking, where we're requesting the balance. And this is probably the one we'll start with, actually. You know, just so we can see the 0.01. Man, it'd be nice if we had 50 Bitcoins. Woot. Okay, but we have 0.01 and some change Bitcoins. That's what we have in this account. Better than zero. Better than zero.
What, $4?
Huh?
It's like $4 or something.
Yeah, something like that. Yeah. And I'll actually have to look into this. We might be able to make it, I think if I invite all of you using my link on Coinbase, you might get a free $5 worth of Bitcoin. So we might do that. I have to check. It might only be if you fund it. We don't want. I'm not going to have you guys funding. I mean, you could do it if you want, but it won't be a requirement for the course that you have to put real money into Bitcoin. All right. So in any case, we're going to get a response on our balance, and this is again simple JSON. So our current JSON parser is capable of parsing this. Correct? We have two variables here. Although this is not JSON. Hopefully that's not what it really returns. Why isn't that JSON? Yeah, this looks like my my pretty output, right? JSON standard, what I have highlighted there should be a colon. Okay, so hopefully this is just somebody typing it in and made a little mistake. So this is JSON-esque. We want it to be standard JSON. Okay, so giving some information about these things up here, just we'll read their description, but I think I've pretty much told you what it's going to be. The access key, that's our API key, thing we already generated. This dude. And hopefully if we click it, it's annoying, but you're glad it's there if you need it, right? All right, 6055051. Okay, so we'll leave. Here's our API key and here's our API secret. We're going to need both of these because so now I'm pretty positive that when we compute that SHA-256, it's called a HMAC. It's a hash function. It's part of the HMAC family of hash functions. We're going to use our key, our secret key, and a nonce to create the computed value. Okay, so we are going to need both of these things. I'm just going to copy it real quick just in case this thing times out or something. All right. So that's our access key. Access signature is our header, which is a hash, SHA-256 hash, the same exact function that Bitcoin is, and we're going to look at doing this with Java, which actually is more difficult than doing this with Objective-C. Kind of interesting. And the nonce concatenated. So access signature is the header, is the SHA-256 hash of the nonce concatenated with the full URL and the body of the HTTP request encoded using your API secret. Okay, got it. So the sandwich that we're making the hash from, remember a hash, oh, remind me, what's a hash?
A fixed length representation of a arbitrary length value.
Arbitrary length input. So a hash is a one-way cipher that takes an arbitrary size input, producing a fixed size output. Okay? So in this case, here's the example of it. Our access signature will be fixed in size in terms of how long it will be. And it's going to be computed between our nonce, which is some integer. We don't know how many digits long it's going to be, but some integer. Concatenated with the full URL request, which would be like coinbase.com/API/v1/balance. So we might have different lengths of those, right? And the body of the HTTP request, which is going to have variable lengths, encoded using our secret key. So the input is arbitrary in size. We can make a guess that it's not going to be ridiculous in size. It probably is going to range from maybe 512 bits up to 3 or 4K, something like that, kilobits. Or kilobytes maybe. But in any case, not huge. But it's always going to give us a fixed size output. So that's what the access signature is. The nonce is a positive integer number that must increase. Oh, see, I didn't lie. At least they follow the right rules with nonce. Positive integer number that must increase with every request you make. The nonce parameter can be included in one of 3 ways. As an access nonce, header in your request. As a get parameter in the URL. As a root level parameter in the JSON post request. So we can provide the nonce in 3 different ways. So we can give it add a header value to our request, whose variable name is access nonce and whose value is whatever the nonce was. And we're going to have to generate that nonce. We'll see what their Java example has in it, but a lot of times what the nonce, how we get that random nonce is by taking there's a long value, a giant integer, that is the number of seconds since 1970. It's kind of a common thing. There's a constant clock in our computers, and most programming languages can pull from it and take and give you the number of seconds since 1970. It's like a weird number. Yeah.
It's systems at current time.
Okay, my guess is that gives you time since 1970. Is that what it gives you? Okay. See? 2 for 2. Didn't lie again. Huh? Not always. Yeah, sometimes. So I reserve the right to still lie to you. Potentially unintentionally. All right, so one way we can pass a nonce is that way. Another way we can pass it using, if we use a get, we can actually pass it as part of the URL. So we can give it $nonce equals whatever. So we can give it a plain text. Now, is the nonce secure? Does it have to be secure? Do we care if somebody knows what our nonce is? No, the nonce is just used to create that access signature hash. We can't reverse that if we had the nonce. Our real secure piece from this is what? Our secret key. How many of you have taken the security class with Professor Wall? Good class. You should take that class. Huh?
I said that
Next semester. One thing you'll talk about in there is something called public-private key encryption. Okay, so we have multiple different strategies for encrypting data, and kind of the most popular one is public-private key. This is our public key. We can give that to everybody. Okay? This is our private key. We don't want anybody to see that. Now, in this particular case, it's not the end of the world because we happen to be doing hashes. And hashes are one-way ciphers, so we can't reverse a hash. The only way we can calculate it is by randomly generating hash after hash after hash after hash after hash with your public key and the body of the URL request and the URL itself and making a guess of your integer, the nonce. And if all those moons align and you happen to guess the right things, then you might be able to produce it and reverse engineer the secret key. By guessing at this, I believe this is a 256-bit hexadecimal value. No, it's not a hexadecimal value. It's got M's in it. I'm not sure what the actual format it is, but crazy long, very random value. Huh?
It's a base 36.
Yeah, whatever. It's a crazy value. I mean, it looks like a hash value, but, whatever. So it's highly, highly, highly unlikely that somebody would be able to crack a hash value. Because with a hash, we're not actually encoding data. We're creating a secure key. We're not taking data, hopefully being able to get it back. Public key encryption, public-private key encryption, often has the goal of reversing it on the other end. So what you do is you keep your private key. You encrypt something with your private key, which it can then be decrypted given your public key. So you hand out your public key to everybody who you might want to be able to open your stuff. All right, so this is even more secure than a typical public-private key situation because we're not actually encrypting data. We're just sending something that hopefully uniquely validates us for this particular request. Okay, so the nonce does not have to be secure. We can tack it onto the end of our GET request, no harm, no foul. Similarly, we can add it as a root level parameter in our JSON post request, where that would be is in when we pass it the body is actually a JSON request, and we could throw it in there if we wanted to. Realistically speaking, we're almost always going to be building things in Java, not as a GET request, well, not as a traditional GET request where we're just building a URL, since we need to attach this header information. We're going to be adding things for access key, access signature, so there's no reason why we shouldn't just throw access nonce in there. Just one more line of code. So that's probably the right way of doing it, rather than taking an extra step to concatenate something onto the end of our URL. Okay, so now, this scheme is generally known as HMAC authentication. Here are some example code, and we happen to have a Java one. So let's look at the Java example code. Now, right off the bat, before we even go down here and actually look at the real code, we're going to have an issue. Here's all the libraries that we need to import into our code. So I'm going to start by just copying all that. Come into our driver program here. And I'm going to paste all those import statements up here. Now notice, these first several are fine. These are built into the Java language. Anything that starts with Java or Javax are available. So we have a crypto library built into Java that has stuff for HMAC and also secret key, public secret key encryption. But now we have all this other crap down here where Eclipse doesn't know about this stuff, this org.apache stuff. What's Apache? What kind of server? It's a web server. So whenever we go to websites, anytime you hit a website, there's probably a 99.9% chance that you are hitting one of two web server software packages. You're either hitting Apache or you're hitting IIS, Internet Information Server. So IIS is if the web server is a Windows machine, Windows server. Apache is if it's anything else. Make sense? So chances are, if I was just guesstimating numbers, and this isn't based on anything, but like I said, I'm never wrong. I would say 75% of the internet is not Windows. So 75% of the internet would be running Apache web servers, and the other 25% would likely be running IIS. Probably a pretty decent number. The only reason anybody would ever run IIS as a web server is A, they're on Windows, and the only reason they'd run Windows as their web server is if they wanted to support .NET websites, which isn't a bad reason, but .NET is one of these things where people who create websites in .NET, they're not stupid, but they're marrying themselves to a specific platform. That is the Windows platform. Okay? Apache does run on Windows, so you could have a Windows server that runs Apache. So there's really two schools for dynamic websites today. One is I'm a .NET developer. The other one is I'm a PHP developer. And then kind of right in the middle, you have a couple of stupid Java technologies like JSP, Java Server Pages, which really never took off. Same thing with Java Servlets. And those things, I've used this in examples in other classes. The only reason, Java only exists for two reasons right now. Reason number one is
Platform independence.
that's reason number 0. All of them are free now. Oh yeah, .NET you can get Visual Studio, the free version of Visual Studio. Doesn't cost anything. Java applets. What's a Java applet? You ever been to a web page and if you ever play Yahoo games or anything like that, chances are all those are in Java applets. It's a full running Java program that launches out of a web browser. That's what a Java applet is. And it's never been done right since. Java's been out for years and years and years and years, and the benefit of it is it's secure because it runs on a virtual machine. Microsoft tried to mimic it most recently. What's the equivalent of a Java applet in Microsoft? That's actually the Flash equivalent. But not a bad guess. That was like a smart guess, but just comparing it to a wrong technology. So if you've ever been to one of those websites that say, this page requires Internet Explorer to use, ActiveX. So ActiveX is Microsoft's stab at Java applets. Before that, it was something called COM. Okay, and it's not that it sucks. I mean, again, this is kind of going to bat for Microsoft. Microsoft has a very difficult problem to solve. We can be Microsoft haters all we want, but they have the largest install base of any operating system in the world. Period. Okay, I still think the numbers might be different now, but I would still bet that Internet Explorer is still the most installed web browser in the world. How many of you in here use Internet Explorer as your main web browser? Very few of us, if any. Any of you use it who just didn't want to admit it? No, we use Chrome or Safari or Firefox, right? Those are your three big ones. Safari is what you use if you're a Mac user, unless you toss Chrome on there. I doubt very many Mac users pick Firefox over Chrome. So they either just stick with Safari or they maybe use Chrome. Are you the stupid one?
Yeah. I like Firefox.
Huh? No, I don't mind Firefox either, but Chrome's kind of come in as the cool kid. Wouldn't you agree? Chrome's kind of the cool kid browser these days. Okay, so I tend to use Safari, and if a page doesn't work in Safari, I launch Chrome. That's the backup plan. It's for no good reason other than just I use Safari. But Internet Explorer is the most used web browser in the world because grandma and grandpa and all the old parents and all these people who use their computer, what do? Get on the internet, click the blue E, right? Well, there's all sorts of security problems with that. They're a huge, huge target. So the people who are writing viruses, they're trying to attack the largest group of people. They're not trying to attack the Chrome users that can run Java applets. Internet Explorer can run Java applets fine, but it could also run ActiveX. And so many sites that want to implement on .NET write their controls in ActiveX. That's why those sites don't work on something else. So ActiveX is kind of innately insecure because they're a huge target. So that's why Java still exists. And really, Java is, the reason that technology is so secure is because it runs on a virtual machine. So you can make many arguments on why is Java bad? It's because it runs on a virtual machine. Why is Java good? It's because it runs on a virtual machine. So it really depends on what you're trying to do with it as to whether or not the virtual machine aspect of it is a good thing or a bad thing. Okay. The other big reason, even just given that, even given applets, I think Java may have actually died off if left on its own. There's another big reason why Java has stuck around, and is really still the third big player. What's that reason? One word. You've all probably either heard it or said it today. You definitely heard it or said it. You definitely heard it today, because I've said it in here. Google. Well, Google's not going to run .NET crap in-house, right? Microsoft's the enemy. They could do PHP, but probably not. Google kind of adopted Java as their language because it wasn't what Microsoft was using. And at the time they made those decisions, they weren't enemies with Apple. They weren't competing with Apple. Apple was a hardware company and made iPods and crap like that, and Google was a search engine marketing company. Now they have bullied up in the same space. So now they're competitors. It's a little bit nastier than it used to be. But regardless, Google is a big Java shop. So for instance, you guys are working with App Engine right now. 100% Java. App Engine, you can either do stuff with JSP, Java Server Pages, which is the Java version of PHP or ASP.NET, or you can do things with Java Servlets. And what's a servlet? Well, actually, it doesn't really even have an equivalent in PHP, and it doesn't really have an equivalent in .NET. It's a server-side dynamic website where everything lives on the server. Nothing's ever transferred back. But in any case, that's why Java still exists. Now, punchline here is, here's some stuff that Eclipse doesn't know about. Eclipse just has the stock Java language built into it. Well, there are some things we need to use here for communicating with post requests and GET requests and client requests that are not built into the core Java language. They're actually part of something that Apache distributes, the Apache web server. Okay, so it's called I think it's called HT Core. That's what it's called, but it's a if you go to hc.apache.org, and then go to downloads, I think it starts with an H. I was already on the right page, and now I just kind of just back up here real quick. Where can I download? Org, Apache, HTTP. Somewhere here, I think they call it HT Core. Yeah, HTTP Core. So it's the Apache HTTP Core. All right, so when you come to this page, you can download any of these. It's going to download as a tar.gz. Cool kids who are old Unix geeks would call that a tarball. How many of you have heard that before? Tarball. So new saying. Sometimes you'll see is a .tar.gz. That's a tape archive and gunzipped, which is like old Unix style zip program, kind of like WinZip. Sometimes you'll see this as just a .tgz. That's the more recent tarball format. But anyways, if you download this on your Mac, you can definitely unpack it by default. On a PC, you might need a program like WinRAR or something like that to unpack it. Once you unpack it, you'll get a folder that looks like this. And inside this folder, you'll have a library that has a bunch of jar files in it.
Wait, is it part of the thing?
Huh?
Well, there's one that's HTTP client.
No, right here is fine.
Okay.
This guy right up here. These are all alphas. These are older versions. This is the one you want. 4.3.5. All right. So just to finish up here real quick, I know we're right at the end of class. In the lib folder, you'll have all these jar files. That's a Java archive. These are the files that will have support for this stuff. So remind me, at the beginning of class on Monday, I want to show you how to bring an external library into your Java program. Okay? So that so that Eclipse knows what these things are. Make sense? All right, I'll see everybody on Monday.